cubics. Cubics are something that, or something that's like this. So on a graph, they're gonna look like this. In cubics, you must know that there is a A term, a B term, an H term, and a K term. The A represents vertical scale factor. The B term represents the horizontal scale factor. The H and the K represent if they either move left or right, or up or down. Okay, so in this equation, we first want to identify what terms we have. We have the A term, the H, and the K. So this A tells you that we have a vertical stretch, and it's also negative. That means the graph is going to go left to right. So let's graph this. Okay, so this HK tells you where its vertex is. So this is going to be a positive 4 and a negative 1. So approximately here. And now this A tells you that there's a vertical stretch of 3. So we're going to go up 3. So 1, 2, 3. We're going to go this way 1. We're going to do the same thing. 1, 2, 3. We're going to go this way. And now we're going to connect our dots. Close enough. So this is how our cubic should look like. Keep in mind A is negative. When A or B is negative, your graph should go left to right, or else it is wrong. Next, we are going to graph this equation. Parentheses half, parentheses x minus 2, parentheses to the third plus 3. So in this, we have a B value, an H, and a K. Our B value is 1/2, which is essentially 2, because when you plug it into the equation, 1 over B, this is where the 2 comes in. So let's graph this. Our vertex of this cubic is positive 2, positive 3, which is about here. Now we have a horizontal stretch of 2. So we are going to go 1, 2, down 1. Here because 1, 2, and then down 1. And we're going to do the same thing over here. 1, 2, up 1. Sorry guys, it's a little messy, but I'm pretty sure you guys can see that. So when you connect your dots, it's going to look something like that. And that's how your cubic should look like. Global or local? Here, let's define these terms first. Global. All this means is the max or min. While local means relative max or min. So here, let's make an example. In this parabola, we have only a global min. At about 1, 2, 3, so 2.5. So at coordinate points -1, 2.5. This is the lowest your graph can go, which is why this is your global min, because this is your minimum. If your graph was something like this, then you'd have a relative max, which is over here, and then you have a global over here, and a global over here. To graph cubics or quadratics, we must know if something is tangent. What that means is that if the graph doesn't cross the x-axis at a certain point. So a part of equation which would be tangent would be x minus 2 to the second. Because that 2 is the exponent, that means it is tangent. In this equation, we want to graph y equals x plus 2 squared, x minus 2 to the third. First, we want to find our zeros that equal. First, we want to find our x-intercepts of these two x's by setting them equal to 0. So in this case, this would be a negative 2, and this would be a positive 2. So let's graph that. Negative 2 and positive 2. As you can see here, this part of the equation is tangent. And since A and B are positive, that means the graph is going to go in order of right to left. So because this is tangent, go up like this, come down, because it shouldn't cross the x-axis. And then because this is a cubic function, we're going to make it look like a cubic. So like that. And that is how you graph this kind of equation.